Good afternoon and welcome to the 5th annual Entrepreneurial Impact Competition. We're very excited to be here to celebrate the students' innovative ideas and the projects they're going to pitch to us. We launched this competition back in 2021. The first couple rounds of this were actually online due to the ongoing pandemic in those days. So it's really great to actually have an in-person event. The motivation was to boost the spirit of entrepreneurship among our students, and I think this year they've really risen to the challenge, so I'm looking forward to the presentations. The 2025 finalists you'll hear from today were selected from an open call for proposals at the beginning of this semester. Individuals and teams of students at both the undergraduate and graduate level were invited to apply, and their entrepreneurial ideas that would lead to improving the human condition. Following a thorough review from our panel of judges, 4 finalists were selected from more than a dozen applications. Tonight we have 2 teams that will be chosen to win a $5,000 prize each. Those were sponsored by our generous donors, Bill Higginbotham, who will be coming up in just a moment, and Greg Zeitlin. The Zeitlin Innovation Award will be awarded to a team based on their creativity and the merits of their project at any stage of development. The Higginbotham Entrepreneurial Award will recognize a team with more developed project, emphasizing their endeavors to bring their concept to market. The finalists are with us today, and they will be presenting their proposals to you and to our distinguished panel of judges that is here in the front row. So please join me in a special welcome to the 4 finalists, which I'll name here. So the first is the Bio-ETTZ, which is a Zeitlin Innovation Finalist and will be presented by Clara Bailey. The second is Biofilm Killer, which is also a Zeitlin Innovation Finalist and will be presented by FeiFei Liu and Shuai Wang. The next team is the FlameAegis AI, which is a Higginbotham Entrepreneurial Finalist and will be presented by Yusen Su. And then finally, Greenstone is a Higginbotham Entrepreneurial Finalist and will be presented by Caroline Tucker, Camilla Roldan, Clara Hawkins, Madeline Jacoby, and Kaylee Jordan. So that will be our 4th team. So over the course of tonight's event, each team will pitch their idea and then answer questions from the panel of judges. The general audience will have an opportunity to ask each team questions during the judges' deliberation break. And so that'll come later in the session. So with that, I'm going to invite Bill Higginbotham up to the podium, and he will serve as our MC for the event this evening.
Thank you, John. If they have me mic'd up, can you hear me? Or do I need to adjust the volume? Okay. I want to start by introducing myself. Bill Higginbotham, class of '76. I got into this position thanks to Don Webster because when he took over the school chair, I complained a little too loudly about the lack of entrepreneurial behaviors in civil engineering. So the first thing he did when I was complaining about that, he said, if we start a class, will you teach it? Didn't really expect that, but I agreed. And I teach now entrepreneurship and innovation. A year later, after I got into a teaching rhythm, and nobody's been further away from academia than me for the last 49 years, I said, well, we need to do something else because entrepreneurship is about making money. So what can we do to create a tangible reward to do something to stimulate the students to do something outside of homework? So that's when we started this prize. And then fortunately, about a year later, Greg Zeitlin, who was representing his father, who was a Georgia Tech grad, he was not, but to honor his father, he came and did a duplicate award. So now the school has this really interesting problem with 2 awards that they're not supposed to be competitive. So Dr. Kennedy Don basically decided to look at conceptual ideas versus more commercial ideas. So I think what you'll hear tonight is you'll hear these teams talking about things, and where they've been grouped has to do with the validity of their idea, where it fits in, where it looks to be potentially commercial. So that's how I got to this position. These judges in front of me, and I'm meeting them all, I think, for the first time. We've been rotating judges year over year, and it's all a quick spot of volunteer work. So we really appreciate you taking your time to do this. I hope that you'll encourage other people who've been in the industry as long as you have to accept the same sort of request when it comes, because this is a program that we are very, very anxious to expand and make larger. We were actually talking about ways to involve the other engineering schools beyond civil in terms of trying to create something that really moves the needle. So this is a lot of fun, but it's too small for our tastes, because we need more people to compete. But let me quickly introduce the folks here, the judges. Chris, we just met. It turns out that his firm and my firm have had a lot of business dealings in the past. Thank you for that, Chris. Chris Martin, you weren't here when I shook everybody else's hands. Nice to meet you. And to be honest, I never heard of the Collaborative Innovation Center within the school. We need to talk, since I'm actually supposed to be teaching that. He's been here and comes out of the School of Biomedical Engineering. Steve Wassel is with Southern Company Gas. I've met your boss too. I'd like to talk to you about that sometime. 25 years professional licensure, civil engineering degree from Georgia Tech. I hope I'm pronouncing this right. Danita Gaines, is that right? Dana? Okay. Cambridge Systematics, which is a transportation safety planning firm. Been in that role for 18 years. And Kim Sanders, this says Air and Waste Management Association of Georgia chapter, where you were formerly the chair.
Yeah, I'm with Stantec Consulting.
That's not on your bio. I know Stantec very well. So thank you for agreeing to do this. The teams are going to have 5 minutes apiece. Corliss has a 1-minute warning sign to the presenters. So the criteria that we've decided on here, I mentioned the difference between the two prizes. It's universal that we're looking for an innovative idea. We're also looking for what's the value proposition and what does it mean? If this is an idea that is commercial, does it move the needle? Communication. How well can your idea be communicated? And if it can't be communicated to the judges, it's probably never going to be communicated to the general public. So as these young ladies can attest, in our classroom, we spend a lot of time on the communication aspects of learning to be an entrepreneur and learning how to be innovative. Because if you can't explain the idea, you're not going to be very successful. And then lastly, what are the odds of some of these ideas actually turning into a commercial service, AI, software products? What does that look like? So in each case, we looked at those, and those are the judging criteria that got these 4 teams here. So the first team, excuse me, I'm getting ahead of myself. After the presentation, we're going to have a few minutes for Q&A, and then we'll move on to the next presentation. So the very first team up is, I would have said this is Bio-ETTZ, but I'm going to assume it's Bio-ETTZ. So please.
Well, hello. Thank you everybody for having me. My name is Clara Bailey. I'm here to talk to you about a new and innovative technology, which is the Bio-ETTZ, or Bio-Inspired Engineered Thermal Transition Zone. Now, before I get into the benefits of this technology, I do want to talk about the fundamental issues that it addresses, which is our human carbon footprint, our global energy usage, and its impact on climate change. As civil engineers, our job is to address industry changes that we can make to better address issues like this. Look no further than the HVAC systems or heating, ventilation, and air conditioning systems like the one used in this very room to keep us cool today. HVAC systems are responsible for 7% of our global electricity consumption or 3% of the carbon emissions that we emit on an annual basis. In the US alone, that means over 100 million tons of carbon dioxide are released into the atmosphere due to the HVAC systems that we are using. With climate change on the rise, the demand that we're putting on these systems is only going to increase. So we need to think about more effective ways to attack issues like this. I would like to suggest that the solution lies beneath our feet. Up here on the right in the figure with the building with these columns stretching beneath it, those are piles. Piles are concrete columns that extend below buildings to provide a foundation system to our structures. Energy piles are a concept that integrate renewable energy with structural engineering. Energy piles are this concept where we take these concrete cylinders and we insert a heat exchange loop inside of them, through which we flow fluid and exchange thermal energy with the ground. The idea behind this is that soil beneath a certain depth holds a constant ambient temperature throughout the year. So based on that time of year, we can either heat or cool our buildings while using renewable energy. On the left side is a U-loop, which is the most simple and easy to install configuration of a thermal loop. On the right side is a helical loop, which is more efficient due to its high surface area, but also due to its complexity is more expensive to install. And it can't be used with all pile sizes. I should mention that energy piles have been on the market for decades. You don't have to look further than the Candida building behind us to see an example of where they failed. Energy piles were in the original design for Candida, but they were pulled due to inefficiency in cost and in energy exchange. The Bio-ETTZ could have been the solution there, and I would like to argue that's the solution for the future. The Bio-ETTZ is a thermalized transition zone that surrounds a pile that allows us to decouple the thermal and the structural components of these energy piles. What this means is that we can design each separately and optimize their efficiency. The Bio-ETTZ is unique in its inspiration that comes from nature. If you take a cross-section of a plant stem, like the gray figure that we see in the center of this slide, there are vascular bundles that run vertically up a plant stem. What these do is provide nutrient transport as well as structural integrity to plants. And we're taking that same concept and applying it to our foundations. Nature isn't wasteful. Energies that waste energy, organisms that waste energy don't survive. And so we're taking that same concept and we're putting it into the Bio-ETTZ. Currently, I'm doing lab testing, and I have a model here if you guys are interested in looking at this for help visualization. But I'm looking at different geometries that are helpful in transferring this thermal energy. Which geometries are most effectively going to do this? The benefit of the Bio-ETTZ, as you can see in the model you're holding there, is that it's also 3D printed, which allows us to integrate this helical loop inside of a honeycomb-like or void-like structure, so that instead of constructing these on site and paying for extra equipment to come install these, you can do it all ahead of time and it can be prefabricated and then installed on site. This results in less cost to the contractor, to the owner, and to the third parties that are involved in printing these. As you can see here on the top right, the Bio-ETTZ has already shown itself to produce a 96% increase in the power output of energy piles. This is a perfect time for Bio-ETTZ to enter the market because by 2027, the global geothermal energy industry is projected to reach $9.4 billion. If the Bio-ETTZ were to capture just 1% of this, that means that we have an opportunity for at least $1 billion revenue, not just in finances, but in sustainable impact. We have also looked into other applications of the Bio-ETTZ. After Hurricane Helene, for example, hit the Southeast recently and left many communities devastated without power, the Bio-ETTZ was looked up as a solution to provide mobile and removable foundation units, as well as insulators for microreactors to provide these communities with power. So as you can see, there are multiple benefits to this technology, all while providing lower costs to both the owner and the contractor in this industry. And thank you all so much for this initial talk, and I yield my time for questions.
Within a typical tile depth underneath the building, you're not going to have substantial temperature differences because your ground temperatures are pretty similar or pretty same. There's not a lot of delta to capitalize with using heat pumps compared to geothermal energy where you're actually tapping into much deeper zones.
Mhm.
So how does that affect your energy use when you don't have the pre-baked heat that you would get from the seismic zone, magma zone, or some of the places where there are significant heat to be harvested?
Right. Good question. So it does depend on the geography that we're looking at. So some areas are going to deal with permafrost levels, and some, this may not be as much of a relevant topic, but at a depth of around 30 feet is where we're seeing the depth in which that we can tap into this geothermal heat sink, if you will. And that's not very deep for a foundation. Foundations can go beyond 200 feet. That's what we consider a deep foundation. In your homes, and depending on the soil beneath the structure, they can go that deep as it is. So we're tapping into this resource that we're already reaching with our deep foundation and shallow foundation insulation. And it's a good point that sometimes you may not be able to, with your standard energy piles, get the heat exchange that you want from the soil. And that's the whole point of this invention, is that to optimize the energy transfer that we have between the structure and the ground, so that now this technology is available in areas that previously were impossible. Does that answer your question?
Questions from the audience?
The panel?
Okay.
Thank you for your talk. My question is about how is it going to be possible to pilot test this in some sort of structure that's larger than what you're doing right now, but not as large as an entire building?
Are you talking about thermal performance or structural or both? Or?
Thermal primarily.
Yeah, so it'll start with scaled models that kind of like the diagrams you see in the lower right there, just in situ testing of a model in the soil without a structure above it, because we're just looking at the thermal exchange as a baseline. Before we want to go ahead and do structural testing or offer these to the public and do commercialization, we want to get solid numbers on the heat exchange that it can do in the ground. And so what we would do there is we would partner with local geocontracting companies and actually get them to do some installation of these piles and the ETTZ, and just to test the thermal conductivity here in Atlanta and start there as a baseline for the performance. The scale for which that we want to do this field testing with hasn't been determined yet, but the typical depth that you look at for energy piles starts between 15 and 20 feet and can go as deep as you want them, depending on the area as well. But here in Atlanta, my understanding is that our goal is to start with about a 20-foot deep foundation and do thermal conductivity testing of that, and then move forward from there.
I'm gonna hold this up, pretend that it works.
Yeah.
Hopefully everybody can hear me. My question relates to the installation sequence and process. And a lot of these piles are maybe pumped concrete, some are driven. How do the different installation practices and the makeup of the actual pile, how and when do you install the Bio-ETTZ material?
That's a good question. So first of all, it depends on the structural pile length versus the ETTZ length. And one of the benefits of this technology being a 3D model is that people can scale it and change it wherever they may be. So it's a very accessible and versatile technology. Now, my thinking and plan for this is that you would use auger cast pile drilling. So you have an auger that goes into the ground, and it depends on the length of the structural versus thermal pile, like I said, because if your structural pile is going deeper and it's got a smaller diameter, then you would have a smaller bit on your auger and go to that desired depth. And then you could take a bigger bit of the auger and then dig the wider depth that would be for the Bio-ETTZ, and then it would just be placed in, and your concrete would be poured in the center, and then grout would be poured into the voids of the Bio-ETTZ. The benefit to this in terms of time and cost for implementation is that if you have a third party printing these offsite, it allows production to go faster, and you're not requiring extra equipment to in place these thermal loops like it was before, whereas now it's all part of this prefabricated parts, so it can be done elsewhere, brought on site. You don't have the extra material costs of the heat loop or the installation process for it. It also allows us to save on material costs, because if you have this larger footprint at the top, again, down here at the figure with the green honeycomb-like pattern, you have this bigger footprint of your pile at the top of it. You're providing more structural integrity to the building. So you can either have a smaller diameter or shorter pile in the center of it. concrete production is known to be very carbon intense. So reducing that, as well as just material costs of purchasing it in the first place, as well as the decreased time in construction because you won't be boring as deep, provides a lot of savings to the owner and to the contractor. So that's what I envision as the installation process.
Looks like this one might be working. Is it working? Okay. So I want to ask a question about the, so you have the pile in the center, right? And this is sort of the honeycomb that goes around that. Is that correct?
Yes.
Okay. So is the thought that these, the sections that you're providing that are 3D printed or however they're manufactured,
Yeah.
that they would be, is the thought there are certain lengths that you would then slide down over that, or how would they be joined together and then inserted as one piece, or any
That's a good
thoughts on how
question.
that construction would take place?
So we're hoping to gauge that a bit by talking to potential customers, because the one option, like that model that you were holding, that was all fabricated in one piece. Obviously, a pile isn't that tiny. So there are industrial sized 3D printers, but in terms of being accessible to different communities and different economies, there's another thought to maybe prefabricate it in pieces and construct it on site for people that may not have access to a very large 3D printer, for example. So there are two options there. And that currently extends beyond the scope of our research in terms of the customer interest and the cost related between the two of those. But those are both two different applications that we're looking at in terms of production that we are hoping to explore.
Is it on? Okay.
Every time it doesn't sound like it sounds to me, but maybe that's
All right. Yeah, my question was actually around had you reached out to 3D printing organizations, companies who could provide the different sizes, and what type of, I don't know if you've looked into this, but as far as like pricing or potential pricing that would flow down to the customer, have you explored?
That's a great question. It does extend a bit beyond
Okay.
our work right now, because we are just starting from the thermal conductivity standpoint before we go ahead and figure out, how much PLA we're using. For example, we need to figure out what the geometry is that we're using, what the optimal design is there, which is going to affect the costs. But that is something that we're in the fall. This semester, I'm working on finishing up this testing so that we can move forward and definitely get into that, because that's a very important part of the product testing.
Clara, you have the 3 examples of the different shapes.
Mhm.
Did you test all of those different shapes? And how did you decide that those were the shapes that you were going to test?
Awesome. That's a great question. And I should also mention there's a circular center that we're using as a baseline, but since it's represented in these two figures here, it's not on the side there, but it's the same exact thing with the circular center. And your question was on how we're testing?
Did you test the different shapes that were shown here?
Yes.
Or were there other shapes that you tested?
So the shapes here are actually based on a simplified version of this gray figure here. Like, it is a scan of a plant stem. So this was our basis for starting. And if you notice, the voids kind of have a gradation as it gets to the edge. The voids get smaller. And there's also, it's a little bit more complex than just a star shape in the center. So what we're starting with is a simplified version of that, constant void size throughout, and more simplified star shapes in the center. We have different, the bottom and the top have the same size concentric circle. The top one has double the amount of points, which is the one that you passed around. And the bottom one has 8 points, which is half the number of the top one. And then that's the same star in the center there, but half the size concentric circle in the center. And what we're doing from there is, before we get into more complex designs, just trying to figure out which of these will have the best thermal conductivity. And then from there, we will move forward into more complex designs and then finalize our prototype. And what I passed around, that is what I'm testing on. There's wax is the medium that we're using in the center, and that hole was for the probe that goes in and reads and generates heat. Any more questions? Awesome. Well, thank you all so much for the opportunity.
Thank you, Clara. The next Zeitlin competitor is Biofilm Killer.
Hello, everyone. Before we start the presentation, I want to ask two simple questions. Do you have a humidifier? Okay, I see. Then this product will potentially help you. And my next question is, do you clean your humidifier once a week? I see. Thank you for you guys. Then maybe this is the product for you. As I just asked, the desire for modern people like you and me seek for a good quality life, make a humidifier is increasingly applied in home and healthcare systems. However, the high humidity and the warmth environment inside the humidifier make a good environment for the bacteria to grow. Those two pictures show the bacteria grow inside the humidifier water reservoirs. They can detach, go out with the mist, and then inhaled by our human lungs, cause bacterial infection called humidifier lungs. Disinfectant are suggested to deal with that kind of contamination, but even safe disinfectant still have high possibility to be inhaled in our human lungs and cause infection called like allergies. Even worse when the disinfectant are toxic. There was an incident in Korea in 2011, which caused an estimated over 20,000 deaths. So what is our strategy to clean the humidifier and clean them safely? We developed a simple and novel electrofield-based inactivation method to clean the humidifiers. The electrofield is produced by the antimicrobial surfaces called modifiers. We have already devised the patent pending method about antimicrobial surfaces-based electrofield treatment. In our design, all the inner surfaces of the humidifier will all be coated with modifiers, and all the possible bacteria near or attached to our surfaces will be killed. The main advantage of this is first, greater sufficient antimicrobial efficiency. According to our live scale experiment data, 99.9 inactivation at 10 volts for only 30 seconds. Then it is safe because it is an electrophysical process which do not have and produce any harmful chemicals which will be inhaled. Third, it is energy efficient because one-time treatment can ensure the surface hygiene for a long time. Last, the high flexibility means this technology can be adjusted to any configuration for customers their demand. Now let's move to next step and potential impacts. Areas where there is colder with increased heat demand and there is a huge seasonal variation would have a higher demand for humidifiers. Moreover, humidifier can also alleviate the dryness. So as we can imagine, the humidifier will be employed more in those arid areas and also cold climate areas. That means they are pretty important for those customers who live in like Montana, Colorado, Arizona, and New Mexico. However, there is no data about customers' profile after 2009, according to Energy Star report. So our following step is a systematic data survey about the customers' preference on the germ-free humidifiers and also their expectation. Our technology also received a 25,000 tech-ready grant from Office of Technology and Licensing to accelerate our commercializing by enhancing stability and flexibility. To get there, we can capsulize our MIDAS to minimize the external environment matrix and also deposit our MIDAS on the flexible subject like our textile and our skin. Lastly, I want to emphasize this technology can also be adjusted to any other situation like our high touch surface like door handle and also the things we use every day. This can help us to achieve the United Nations Sustainable Development Goal 6, which is global sanitation. I want to emphasize this is not only about around 20% of the US households and Canadian households who own the humidifier. It is also pretty important for those customers. It's also important for those 2.8 billion people who don't have safely managed sanitation, and also 1.9 billion people who don't have basic hand hygiene facilities. So lastly, I hope we can all agree that with this technology, this is not only about money to be made, but more importantly, lives to be saved. Thank you.
Okay, I'll go first. My question in my head maybe has two parts. The, can you describe, this biofilm, does it require a low voltage power source?
Yes. Mhm.
And so you mentioned the applications such as door handles and so forth. Would those be retrofitted in some way to provide that power source?
Yeah, we actually, for door handles, actually, we didn't think about pretty detail, but for the humidifier, we think it's because, the humidifier, they also need the electricity to make them work.
Yeah.
Yeah.
And when you were talking about that, for my daughter, we had a humidifier in her room when she was a child,
Mhm.
asthma. And we also had nebulizers and things like that. So there
Yeah.
are certainly and you mentioned certainly other applications for something.
Mhm.
I just wanted to clarify. So
Yeah,
I'm saying.
Hi there. So a couple questions about the matrix that you showed of all the wires. Is that a really small spacing, or how wide is that? And what kind of voltage do you put through? Is it higher voltage or just a very low amount? What does it take to actually kill the germs?
Yeah, we applied the like 10 volts around that it can achieve 99% inactivation at 30 seconds. And we also observed that for one-time treatment, like 1 minute, it can ensure at least for like 2 days, the like surface cleaners. But this is based on our like experiment data, yeah. And we are expected to do some like prototype with this commercialized humidifier and test its durability and prevention efficiency in that prototype.
Thank you.
So my question is maybe a little tactical, but definitely had a few humidifiers at my house that could have used this technology. And my question for the two of you is maybe twofold. Have you started to think about what applying this technology to a humidifier would do in terms of the cost of it? Is that something that you all have been able to explore yet?
Yeah, we're concerned about maybe our Michael could help.
Yeah. Customer service and market research is very important. And basically, we are doing this humidifiers in the lab scales, and we get some of these excellent data from this. But in the next steps, we want to do more about the market survey to find out how many users want to buy these humidifiers and what is humidifiers. So for example, if the user's age distribution and maybe the geographical distributions, and found how many users will buy these humidifiers in the future, and we want to figure out what is maybe the humidifiers price range and what is the lifespan of the current humidifiers. Do this market research, and next step, beyond this market research, we want to produce several prototypes based on our MIDIS technologies in our lab, and we also want to test these prototypes like the overall performance, like the inactivation performance and the energy performance, even the lifespan of our humidifiers. And in the future, maybe we will put our prototypes into Georgia Tech, for example, in the buildings and in the offices to get the feedbacks of the different users to improve our humidifiers.
Okay. And actually the part about the benefits or the lifespan was my other question.
Yeah.
Did you consider in terms of looking at the benefits of this this work, how it could result in people using a humidifier longer? You know, sometimes people have a humidifier that has a lot of mold in it, and so they just get rid of it and get a new one. So there's some sustainability benefits to the technology that people may use the same humidifier longer, and that might also impact what they're willing to pay for the humidifier if they can use it if it has a longer life cycle. Have you been able to think about that a little bit?
Yeah, thank you. That's a good question. Here is a humidifier. We want to show that it really has some biofilms of the mold inside it, but sometimes, as we asked before the talk, many people, they forget to clean their humidifiers recently. That is why we provide our automatic humidifiers to the users. And we want to set up for this to Yeah, my partner mentioned that our inactivations for the process mainly it only takes 3 seconds for the self-clean of these biofilms. So every time you use it, it only takes 30 seconds or even 1 minute to this. So our MADIS technology can use for at least 3 to 5 years based on our lab scale test. And this is for the lifespan to help the users to use longer for this. And for the second is that the accessibilities, which is currently that our MADIS used in our lab is basically made from the metal materials, and it is environmental friendly. And these materials will help this to get a high inactivation efficiency and with environmental friendly sustainable, I think.
Thank you.
Yeah.
Thank you for your talks. Have you done any analysis of disinfection-based byproducts that you might get using this method?
Yeah, that is a pretty good question. That is to monitor the potentially harmful byproduct is also one thing we want to do. That's if we want to build a prototype based on the MIDAS surfaces. But I want to say based on the inactivation mechanism, because we use the electrophil-based inactivation, which is the electrophysical process. In theory, it shouldn't produce, I mean, at least it can limit the production of disinfection byproducts, which will not be that issue for our our product. And another thing is that even though it is an electrophysical process, and we would, I mean, in the future, as I just showed that we already received a 25,000 tech credit grant. So actually we want to enhance the stability by coating a layer on our surfaces, which can also, for example, enhance the lifespan and also reduce the potential harmfulness from these surfaces. Thank you.
Is your technology patented at this time? Like, do you have a patent or any type of thing?
Yeah,
Or
actually,
can I?
Yeah, we showed schematics.
we have
It's like this.
schematic.
Yeah, we want
Okay.
to pattern all these MADIS on all this inner surface or the surface of the humidifiers, like this parallel patterns here.
Okay.
It is actually,
Is this built into an existing humidifier, or is it a modular unit that you would put into an existing humidifier?
thank you. That is a good question. We are thinking about that. So we would prefer actually to integrate with that the existing the home appliances brand because we think the humidifier they have their own mechanical fundamental inside it, and we are not that major, so we think maybe just leave that into those professionals. They can do that better.
You're really gonna, if this takes off, you're really licensing a technology to a manufacturer,
Mhm.
correct? And if you were going to do this on a retrofit, like a modular system, how would you have to have a battery operated and a battery change involved if it was a drop-in as opposed to being manufactured in? 'Cause
Yeah.
You mentioned low voltage and short bursts of electricity, but that means if it's not part of the manufacturing process, you wouldn't have the transformers to have the low voltage. You'd have, circuit power.
Yeah, thank you. That's a good question. That is what we want, that we want to couple our MIDAS electrodes with the humidifiers together. Once the user want to use this humidifier to clean the humidifiers, just to plug the chargers, just to put in the plug in the chargers, and it will run automatically. And the monitors and the other programs will coupled with the chips inside the humidifier, so it can set by the users. Maybe you want to set once a day or twice a day, or others different times you want to set up with these humidifiers. It's automatically with this. We needn't to use a battery or others to charge it.
Any other questions? Thank you very much. team is FlameAegis AI.
Hi, everyone. My name is Yusen, and today I'm very glad to have this opportunity to present my venture idea, FlameAegis AI. So before jumping into my product, I want to show a brief videos which captured by the Department of Fire and Rescue. And this video shows the real working environment of our firefighters, especially during the wildfire season. And this devastating scenario does not just impact our community safety, but also the lives of the firefighter. I also have some data for you. According to the Congressional Budget Office, United States spent 2.5 billion US dollars on fire suppression only, and there is 81.6 billion US dollars in wildfire-related damages from 2017 to 2021. And unfortunately, the wildfire is projected to increase by 50% by the end of this century. And according to the United States Forest Service, they report that they have constant firefighter recruiting shortage issues, and they cannot maintain the enough number of firefighters in all seasons. So our mission statement is we want to empower firefighters with cutting-edge tools and a situational insight to help them be more effective against a multi-scale forest firefighting. So our product will be consist of three parts: the digital twin-powered fire prediction model, drone-aided computer vision monitoring system, and a real-time firefighting operation platform. We will collecting and analyzing the data from multi-scale information sources, from the satellite images to drone captured videos, to the physical sensors and the personal devices. In one sentence, a multi-scale solution powered by algorithms and an integrated platform is our core. So our business will generate profit from three channels. First, our customer can purchase our integrated drone product at once. Second, if they want to access our interactive operating platform and a prediction model, they probably could pay the subscription fee. And we will also open to provide specific need solution consulting service. And then let's talk about market. We position ourselves under the total market of global wildfire management market, which has 2.6 billion US dollar market cap, and under which the addressable market is global wildfire detection market, which has 700 million US dollars market cap, which is actually a conservative number because our product features is beyond just a detection, but we use that for now. The target market is then the 7% of the addressable, which is 50 million US dollar. Then you may ask, why us? Why FlameAegis AI? Then compared to many successful companies on the market, we are providing both situational awareness and decent scalability. For instance, compared to the company Ring, represented by the character R on the graph, they're providing pretty good situational tools, but they are highly reliant on the helicopters and the firefighting plan, which is our very expensive asset for the fire department. And that's hard to scale based on that kind of solution. And on the contrary, the drone amplify, they're using the drones to assist the firefighters to ignite the scheduled fire at some locations that firefighters are hard to reach, but they are not analyzing any data. So we have this competitive in this two area. And now regarding the marketing plan, we have three stages. The first stage, we will spend 1 year on research and development to have a first generation mature solution. Followed by that, we want to establish government partnership regarding the use of the technology and the permit. From the first year on, hopefully we'll be able to deploy our solution in at least 30% of the national forest system land. And our sales strategy is pretty straightforward. We talk to the firefighters, and we want to make sure our solution is as easy plugin as possible, which can be fast deployed by to their current process. And we are currently entering into the Great Axe. Hopefully, we will be able to work on that in the summer. And about the financial projection, after the preliminary analysis, we have the break-even point of on average cases of 2 years with the assumption of a market penetration rate of 0.3% and a 600% growth rate. Thank you very much.
See an AI component, I see a sensor component, and then I see what looks to be a pretty traditional drone. What's the primary focus? Is it in terms of interpretation, or are you suggesting it's a form of instrumentation that gets mounted on the drone?
Yeah, that's a great question. So as we mentioned in our one sentence competitive product plan, our key is on our algorithm. That's because Drone is just information sources which can capture the videos for us. So our algorithm can actually apply to the firefighting plan as well, and other camera-based information resources. And what our algorithm, where the AI makes the difference, is because we will analyzing the spreading speed of the fire based on the videos input, and which is we are not just capturing the videos and send them to the stakeholders, but we will analyzing the speed based on the images and the camera and the videos captured by the camera, so that to provide an analyzed insight from the sources. We are not just simply provide raw information, but we will process that from the algorithm, which is where the AI plays the roles. Thank you.
Have you considered, like places that have wildfires recurring, like, every year, each time of year? Is that information plugged into the AI model? And as far as doing any type of predictions, for fires and, as climate change occurs, there's going to be fires in other places that may not have had fires before. Is that baked into your product?
Yeah, I think that's a great question. So according to our research, the fire management market, they're typically consist of like pre-fire, during the fire, and post-fire. What you mentioned just now, it's more about the pre-fire stage, and that's also a part of our product will deal with. But just as I mentioned, some of other companies, they probably have already provided kind of solution that can monitoring the forest and provide the early detection of whether there is a fire or the smoke in the forest. But our market, our product are position ourselves for during the fire stage. So our algorithm are mainly dealing with the computer vision, using the computer vision techniques to deal with like the estimating spreading speed of the fire from the videos, and so that we can allocate the resources accordingly during the fire, because the resources are always limited during the fire season. So we want to put off the most dangerous fire front line and to probably narrow down the spreading areas of the fire. Thank you.
So you talk about building the algorithm, and, obviously with AI, as you have more video footage to build an algorithm, your algorithm improves, right? So how are you building the foundation of your algorithm? What are you using before you are able to use this in a situation where you actually have video of fires, where you can use how do you build your prediction algorithm prior to having that video footage that you would be collecting more from whomever is using the product, so you could build out that algorithm with more certainty in the prediction. But prior to that, you have to have an algorithm to begin that process. Where are you going to get that information from?
Yeah, that's a great question. So that's also part of my current research. Firstly, there is some fire captured by the drone that is public right now. They're already kind of the scheduled fire where the research team gets a permit to capture the videos by the drones on the site. And that kind of real world videos we will use for validating our algorithm. And in addition to that, so the data sources limited, the limit data sources is always a problem of the AI application. So what we are doing is there is some data set that are generated from the high fidelity simulation techniques, that is computational fluid dynamics. They provide the result of how the fire would spreading and growing with different conditions. And we are using that kind of result to generate the videos and the animation from some 3D rendering software. And we will testing and training the algorithm on that kind of data sources and validate it on the real world videos.
And just as a follow-up, the consulting piece that you also included, what types of things would you be consulting your client on? Say you have the technologies being used by a city or county fire department, they have the video footage. Are you consulting them? Are you looking at the videos the drones take after the fact and looking at the predictions there? Or what is the added value of the consulting product?
Yeah, what my original thought about the consulting is I want to try to, because like in the real world firefighting process, the fire department, maybe for the wildfire, but also the urban fire, it probably will face some very specific problem that is unforeseen before they use this kind of product. So we are just open to provide additional consulting and analyzing the validation of different ideas, and if we can provide like different products to them to solve the specific question or specific problem. Yeah. Thank you.
Question's a bit related to that one, but when you were developing this, how many firefighters involved in wildfire management did you talk to? What kind of feedback did you get?
Yeah, I think I talked to several firefighters, and the feedback they provide to me is generally the firefighters would be more stubborn to their traditional process, and as well as the department manager to the traditional process. So that's a feedback we get to establish our selling strategy. We want to make sure, firstly, our product is as easy plugin as possible. We don't want to completely transform their process. We just want to provide them more information sources so that they can analyze it and take into consideration while they're operation the firefighting. And secondly is our solution would be like the full stack. So they do not need to worry about any technical part of the product. Thank you.
A question related to, you mentioned that the drones would be flying during the events, right? So my question is, if you have firefighters trying to target the fire with airplanes dropping, helicopters dropping water, how are you? Anyway, it just seems like there could be a conflict between those aircraft, the turbulence of the fires producing, and the drones going in there that are, trying to provide the data. Have you thought much about that conflict?
Yeah, I think that's a great question. I also thought about that, especially when I think about, because currently some government, they do not permit the drones to use on the site because it may have the conflict with the flight and with the plane and the helicopters. But I think the main problem about that is most of the drone currently appear on the fire location is unauthorized. They do not have any modules that can communicate with the plane. So, but this is, I think that can be solved by a system engineering approach, to avoid, for instance, if the plane is operating, all our drones will just back down to a safe zone.
Thank you.
Thank you so much.
I have a question so much as maybe a comment, and that related to the algorithm and feeding it as much data as possible in order for it to give you the best result, right? And so, you know, it can certainly pick up things through video, but prior to the event, if the local municipalities, fire departments, if you had information on from GIS mapping,
Yeah.
where all the fire hydrants are located, where the reservoir or the storage tanks are located, which ones might be dry or down. Does fire department number 5 have an engine that's not working? If you can aggregate that type of information at lower level, that might be better feedback. And then as far as all this goes, you need to charge a subscription.
Yeah, that's also part of our proposal. Yeah, thank you.
Carlos, can I get what?
Thank you.
Thank you very much. Last is green.
Good evening, everybody. My name is Caroline Tucker, and I'm here today alongside Clara Hawkins, Madeline Jacoby, Kaylee Jordan, and Camila Roldan. We are all civil engineering undergraduate students brought together by our passion for sustainable infrastructure and its place in our rapidly changing world. Greenstone was founded to address two urgent problems. Problem one, the United States construction industry contributes roughly 500 million tons of concrete waste to landfills every year. This isn't just a landfill issue, it's a climate issue. These materials release significant amounts of carbon into our atmosphere, accelerating climate change. Problem two, our changing climate is resulting in more intense rainfall across the United States. Since 1901, the US has experienced a rise of 0.18 inches in average rainfall each decade. This intensifies challenges related to stormwater management, especially in urban paved areas. Here at Greenstone, our mission is to develop innovative, sustainable stormwater solutions that transform construction waste into resilient infrastructure, reducing carbon emissions and enhancing the built environment.
Greenstone was imagined around 4 guiding principles: enhanced stability, improved water management, and exact precision and easy installation. These 4 principles are brought to fruition through our 2 groundbreaking products, Green Paved Tiles and Green Web Reinforcement System. Green Paved Tiles are made of up to 75% of recycled aggregate, using a 1:4 cement to aggregate ratio and a 3:10 cement to water ratio to ensure for sufficient void space between the particles for the permeability feature. Then we have Green Web, another integral component to our permeable paving solution. Green Web is a reinforcement grid made to support Greenstone. This grid is an expandable, flat folding system with living hinges at the joints to ensure for easy installation and uniform tile placement. It is also important to note the hexagonal design that allows for reduced stress at the corners, making it less prone to deformation. Green Web will be produced with compression molding to ensure for uniform tile placement. 20 green paved tiles or 1 unit of Green Web will cover about 10 square feet. Each of these tiles will be installed. You would lay down the Green Web, then place the green paved tiles on top and brush recycled aggregate into the webbing gaps. Overall, our production cycle is very efficient as it maximizes production while minimizing costs. We plan to partner with local demolition sites and recycled HDPE suppliers for these materials. Greenstone will be a leader in eco-friendly infrastructure solutions by 1, reducing the amount of construction waste using up to 75% of discarded waste in our products, and 2, maximizing groundwater recharge.
So our product stands out in the market for 2 key reasons. First being ease of installation. Greenstone simplifies installation, making it more accessible for homeowners and contractors. Our Green Web can reduce installation time by up to 65% compared to traditional paver laying due to our optimal tile spacing and effortless aggregate infill. Second, sustainability. Our tiles are made from 75% recycled construction waste, and our webbing is 100% recycled HDPE, leading the industry in eco-conscious materials. Beyond this, Greenstone offers consumers durability and aesthetic versatility. Our webbing does not just streamline installation, it enhances stability, preventing shifting and reducing long-term wear and tear. The demand for permeable pavers is growing rapidly, especially as cities look for solutions to rainwater management. By 2024, the market reached $3.3 billion. Looking at our financial projections, we show strong growth, reaching profitability in just 26 months. As demand increases, our net income is expected to scale rapidly, surpassing 5 million by year 5. With a product price of $12.69 per paper, $169.99 per web, and a production cost of $8.50 and $92.67 respectively, we are well positioned for long-term success. Looking forward, we hope to enhance the load-bearing capacity of our papers, making them suitable for low-intensity traffic uses. We also hope to increase our product customization options, including a range of sizes, shapes, and colors. Greenstone is more than just a paving solution. It is a commitment to sustainability, efficiency, and durability. With our industry-leading recycled content, innovative installation system, and strong growth, we are paving the way to a greener, longer-lasting future. Thank you. I'd like to open the floor for questions.
So who do you see as your customers in this? Residential, commercial, construction? What?
So initially, we're going to target residential areas and hopefully landscaping contractors locally, obviously. The idea is that this will be used for patio or outdoor seating areas and walkways. So that's where we're going to initially start.
And would this, just as a follow-up, would this be rated for vehicles to drive on, or is it mainly for patios or walkways?
Initially, it's patios and walkways, but like Clara stated, we want to hopefully in the future pursue this being like
Load bearing.
yeah, like more load bearing for low intensity traffic so that it can be used for driveways and parking lots.
The cement to aggregate ratio, it's based on like traditional permeable pavers. It just has that 3:10 cement to water ratio. That's like the higher permeability feature, but that means that like right now it's like load bearing as like most like permeable pavers, like a car couldn't drive on it, but we like continue testing to just like perfect that ratio and see if there's like a way to make it more load bearing.
I have two fun questions. So there are 5 of you in this group.
Yes.
I would love for you to share like what each of you brought to this project and contributed, because I'm sure it was something different for every person.
Sure, yeah, we can go down the line. So we had the pleasure of taking Bill's class this past fall. So we were a team of 5. This was our final project, which we were very excited to present to you all today. So we all kind of broke down into C-suite roles. So in terms of this project, I was the CEO. So I would say in terms of bringing it here to the EIC, I oversaw a lot of the management and the organization, and I was the one that was in contact with Casey to get here today. So a lot of the question run-throughs and organization. So I would say that was my role. Awesome. And yeah, so in this setup, I acted as our COO. So as Caroline handled a lot of the external work, I kind of tried to run things from the inside. I made sure everything was as organized and as timely as possible, which was a lot, working with 5 people, making sure we were all on the same page. But yeah, I just tried to help out wherever I could and make sure we delivered the best end product.
I was our CFO. I mostly worked on the financial projections, but also just helping out wherever was needed.
I was the chief marketing officer or the chief communications officer. I did the market analysis and the value proposition, just what was going to make us stand out. And we also ran through a bunch of risk scenarios, like how we were going to get our market out there and like what was going to make people want our permeable paving system over any original like permeable paver.
And I was the CPO, so in charge of like the technical stuff. So lots of researching into like similar permeable paver companies and how we can like outshine in that area. And then also we met with our civil like materials professor, Dr. Dye, and he was a great help in like seeing the feasibility of like of the ratios and yeah, making the permeable aspect out of sustainable material.
Okay, thank you. And just very quickly, if your group wins this prize, what will you all do with the prize to advance this product?
I think we would mostly want to look into doing more researching and patenting. Like Cami was saying, we need to do like a lot more testing to see where we can get to in terms of load bearing. I think if we can tap into the like vehicle market, that would really expand the application of our product. So I think we would really want to invest it into R&D and making sure we're like taking this technology as far as it can go. I think it would be also super interesting. As you could see, our model that we showed to you today was 3D printed in my roommate's dorm, actually. So I think it would be really cool to take the $5,000 and pursue specifically the green web application in maybe a larger sense, or with different materials than just 3D printed filament.
Thank you for your presentation.
Go ahead. No, go ahead. Go ahead.
Yeah, my question had to do with, so one of the things that falls is rain, but you also have things like pollen fall, which seems to be higher than rainfall sometimes. You have dust and you have sand in certain parts of the country. You could have things that industrial plants spew into the air. How can you test the impact of all of those? I mean, I realize it's unrealistic to test everything, but how can you test some of those to see what effect it will have on your product?
I think that's a very good question. We've looked because we thought also about that question, but in relation to like freeze and like thaw and like extreme temperatures. And I think we're at an advantage that the materials that we use are very like resistant to that, like recycled HDPE. I think could be like cycled through like up to 6 times. I don't want to make up numbers, but a multitude of times. And it still like has that extreme like resistance and durability. And that's what we will use for the green web. And then as for recycled aggregate, I feel like it's also like a common material and it's known for like its like strength in a variety of environments. So I think that, yeah, we're at an advantage that the materials that we're using, they're pretty like adaptable. But if anyone else wants to expand on like as for dust or anything.
I mean, I can expand on that a little bit. Right now, I feel like we haven't really looked into like the dust and the pollen and everything. We're targeting the Atlanta metropolitan area. So I feel like we can definitely look into that more and consider like the things that we would typically see around here, such as pollen, because we've seen one of the highest counts we've seen in a dozen years. So I think that's definitely something we would have to look into further.
Yeah, my question is for the marketing business development person. I do a lot of that. My career is kind of more from civil engineering to doing what you're talking about. Who do you see? I know you mentioned starting out with residential, like, you know, what are going to be your markets, and have you considered where you would want to get your disseminate your information? Would it be through lunch and learns?
Okay,
Or would it be
so
through conferences or things of that nature?
So we discussed it a little bit as far as like where we wanted to first like set our market out. We definitely want to get a website up and running. And then as far as like partnering with local contractors that are like in landscaping, we hope to reach our audience through that. Hopefully develop a partnership with them so that they can take it to people that would normally come and explain what they want done in their yard or in their house. But yeah, we would just hopefully start with a partnership with more local landscape contractors or like smaller hardware stores. We would hopefully get that in the store eventually so that people could just walk in and they would be able to see our system, because like we said, it's like it makes it very easy for those pavers to be installed, and that's like why a bunch of people don't buy permeable pavers. So yeah, does that answer your question? Okay.
So you'll have a manufacturing component basically.
Yes,
If you make this off the ground. Have you looked into the type of equipment that's going to be necessary for the different processes? You have 2 distinctly different materials, right?
Yes, sir. So the first is the green pave towel. So that would be like the standard like molding and curing for permeable tires, and then for permeable pavers. And then the second is green web, which that would be made of the 100% recycled HDPE. So we looked at different like molding systems, and we saw that the best was like compression molding, just for the shape, and it's good for like mid-size production. And because the other one would be like injection molding, but there's the risk of like uneven load distribution. So we're going with those 2. But then as for the like quality testing, what gets like more specific and like meticulous, we're thinking of like outsourcing that. So we would just do like in-house like dimension and like regular like visual inspection. But yeah, before putting it out into the market, it'll be outsourced.
Any other questions? Green Star, thank all the competitors. At this point, everybody but the judges are going to go out and they need about 15 minutes to run through their notes. We're going to come back in and present the awards.
All right, everybody, welcome back. Everybody, all right. Excellent presentation. I touched earlier on the nature of the prize and see how they got distributed. And so we're going to stay in order, and we're going to the warrant the Zeitlin prize first. Don is going to present the check to the winner. And I'm pleased to announce that the winner is, drum rolls, please. Hey, Biofilm Killer. Oh,
Yes, folks. Got those. Well, she's moving. Congratulations. Okay. Again, congratulations. If you take that, this is where it did not. Actually, you get some result. Oh.
The second prize, Higginbotham prize, I'm very pleased to announce it going to Great.
Ready.
I'm sorry, everything. Please again.
Let me thank the judges for your newness. Like I said, this is the 5th year we've done this. The judges have always taken time out of their busy day to come and do this. Appreciate everything out done. I appreciate the audience. We have a former winner in the back, and John Van. So the reason that we're doing this is to create a more entrepreneurial community. So this is one step forward. I'd like everybody here, whether you're a professor, administrator, student, or a winner, go tell everybody about this. We think this is something that's really special and it can be made bigger. Personally, I'd like to see this in the cabbage with multiple teams and more digits on the big checks. But we're starting small, but we want to make it bigger. So I appreciate everybody for coming, and this is great stuff. Thanks, Greg.
Thank you, everybody, for attending. The presentations were wonderful. I really enjoyed it. Thank you to our judges for taking time out of your schedules to join and to listen to the presentations and bring you wealth of experience to considering the prizes. And let's see. There are light refreshments that are out there. Those of you that were asked to leave, you saw that they were all set up. So we're going to go out and enjoy that for a few minutes. I really want to thank Bill and his wife, Elizabeth, for their generosity for supporting this prize in particular, but also the longstanding support of the school. So thank you both for that. Well, enjoy your evening. And
lastly, Dr. Kennedy, thank you for allowing this to get knitted into the global engineering leadership minor. And this is a great program. So thanks for your acceptance of all of this.
I want to take the opportunity to say thank you to Lisa Rosenstein. She has tirelessly worked on this initiative, and this is a wrap.